Exercise 18D, inverses. Here we go, let's have a look. One thing you should pick up is we learned how to add, subtract, and multiply by a scalar. And then we learned how to multiply matrices. But the one thing I didn't teach you was division. Because there is no division in matrices. Okay, so then that arises a problem. If there's no division, then that means when we're solving for, let's say, this matrix, it becomes tricky because we can say matrix A times matrix X plus matrix B will give you a resulting matrix, and that matrix is C, right? The problem is if you wanted to find out what matrix X is, what you can do is you can add, subtract, you can multiply. So that means you can subtract B. So that's fine. Matrix B cancels matrix B. That makes sense. Then you're left with A multiplied to X. So matrix A times matrix X equals to C subtract B. Okay? And the problem here is, well, what you need to do is to remove the A. And that's your goal. Your goal is to remove A so that you can find out matrix X. But we don't have a division. You see, in algebra with numbers, we could. Because if you got times 3, you can divide it by 3. And 3 divided by 3 cancels out to be 1. And 1 times anything, it's itself. So what I'm trying to say here is I'm saying 3 times A equals to, let's say, 12. You can solve this because you know that you want to change this. You want to change this whole thing. You want to times this by something and times this by something such that whatever this answer is, times A doesn't change A. And what we found out is we can do the inverse of times, which is divide by 3. That's why a third of 3 cancels out to be 1, and 1 times A. This is a key thing. 1 times A, we like that because 1 times A does not change A. And that's how it allows you to find out what A equals to. So whatever you've done to the left-hand side, you can now say times this by a third, and that cancels out to be 4. That's why we know A equals 4. And we divide both sides by 3. So that works with the numbers. But remember, with numbers, there's a bit of a difference with matrices. With numbers, you can say 3 times 2 equals 6, and 2 times 3 still equals 6. That's okay. Matrices, what you would have done if you've done the exercise for 18C, you realize that matrix A times X does not equal to X times A. So therefore, division is not also possible as well. Okay? So, because of that, the question is, what are we trying to do? Our goal is exactly what we do with numbers here. Our goal is to times matrix A by something so that you get an equivalent value or matrix such that when you times it to this, doesn't change it. So what I'm saying is I want to times something to A so that it cancels the A, but it remains as X. It doesn't change X. Okay? And so this is what I'm looking for. I'm looking for something. I'm going to draw it here. So you want to multiply this by something. Whoops. And you want to multiply this by something. Something on this side and something on this side. Because remember, matrices, it does matter which order it is. If it's A on the left or A on the right, it does matter. And if I multiply A to the left, something on the left, I have to multiply it on the left. What I'm looking for is something that multiplies to A, and it cancels out, and it becomes something. Something. So we normally call that I, and I'll tell you what I is later. I, such that when you multiply I to X, it is the same thing as X. That's what I'm trying to do the comparison. So I is your 1. That's what you want. So I times X needs to give you X. 1 times A gives you A. That's what we're trying to look for. And today, at the end of these slides, I will show you how the formula works. But for this slide, you're going to copy the notes because I'll tell you what they figured out as that value. And we call that the inverse. Okay, so there's no division, it's only times. So I'm using times here. I'm trying to times it by something, and that something is called the inverse. That's what you're looking for. Okay? So that's all I want you to understand on what I'm trying to say here. Why the inverse is so important for you to understand and get your head around. Because if you understand it's solving, it makes a lot of sense later what you're really doing with matrix inverses. Okay? All right, I'm going to take all this out, and I'm going to get you to copy these notes here. So, this is what I'm trying to say. I'm trying to say that there is this I matrix, some matrix that if you multiply to A, it doesn't change it. It's like a 1. We want it to be a 1, but we don't know what that matrix is. And so they figured out that if it's a 2 by 2, and this only works for a 2 by 2 at this point, 1001, if you multiply this to any matrix, it stays the same, any 2 by 2 matrix. Okay, so for example, if I said A was equal to 2, 3, 1, 4, and I multiply this to I, doesn't matter which order, whether I is on the right or on the left, it's still going to be the same. And they found out that 1001 is what you're looking for. And this is what it'll be. So if I did A times I, here we go. 2, 3, 1, 4 times 1, 0, 0, 1. Let's see if it's still A. Row 1 times column 1. 2 times 3 plus 3 times 0. 3 times 0 is 0. So 2 times 1 gives you 2 in row 1, column 1. Row 1, column 2. So 2 times a 0, 3 times a 1. 2 times 0 is 0, and 3 times 1 is 3. And then I do 1 times row 2, column 1. So row 2, column 1 is 1 times 1, which is 1, and that's 0. So that becomes 1. And finally, 1 times 0, which is 0, and 4 times 1, which is 4. And conveniently, A times I does give you matrix A. So we call this, the reason why it's called I is because that's called the identity matrix. Okay, I'm going to write it next to it. This is called the identity matrix. Why do you need to know that? Because I told you, your goal is to multiply something to this A, and we know it's called the A inverse. We want A inverse to cancel out to be I. Because if it's equal to I times X will give you X. And that's what you've been looking for. That's the goal. You're trying to find out X. Okay? And that will cancel out to be I. Why we want I? Because I will give you the same matrix. Whether you multiply left or right, it doesn't matter. That's the importance of the identity matrix. Okay? And that's the goal. Okay? Now, the question is, well, how do you find out that A inverse? So I said multiplied by A inverse. What is that equal to? How do you find out the A inverse? And there's this formula. Towards the end of this PowerPoint, I'll show you how it comes about and the logic as to what it is. And therefore, it makes more sense what the determinant is. You don't have to memorize. It really goes back to year 9 mathematics. You understand straight lines, this whole thing makes sense. Okay? But for now, this is what I want you to do. I want you to copy these notes here. This is your A inverse formula. You're going to memorize this for now. And towards the end of the session, I'm going to explain where that comes from and why that is and why it's important to understand that formula. Okay? Over here, this is what we wanted. I said I want A times an inverse matrix because that, we don't have a division, so we have to times it by something, and that's the inverse. I'm going to write here, this is your inverse matrix to get I. That's what we want. We want I. How do you get the inverse matrix? That's how you get it. So for any matrix A, to find the A inverse, whatever A is, A times D and B times C, that's your AD minus BC. Your A stays the same. Actually, sorry, that formula's wrong. It's DA. Sorry. There you go, fix that. It should be DA. You swap the positions of D and A and negative B, negative C. For now, it doesn't make sense. I know, I get it. Memorize the formula. Okay, it's like a quadratic formula. Later on, I can teach you where it comes from. For now, you memorize quadratic formula. For now, you're going to memorize the A inverse. Okay, so the inverse formula. Because it's quite a bit to take in from today's session, because you're going to analyze AD minus BC, what it actually means. What does it mean when you have an A inverse, when you don't, how that relates back to X. And with my year 12s, I took at least 2 sessions to get them to get their head around it, and they've mastered it, but it takes a while to get your head around it. Okay? The nice thing is you're in year 11, so you're going to repeat it here in SPECH, and you're going to repeat it in methods, so it's an easy concept that you're going to get. Okay? All right, we copied all the formulas? Yes? All right. Here we go. Let's go through a theory. Let's do a bit of practice now, okay? So examples of inverse, get yourself a bit used to finding the inverse. So here we go. We've got matrix A. I made it up, I said 3, 2, 1, 6. I've got A times some other matrix, and that gives me 5, 6, 7, 2. I want to find out what that matrix is. Okay, so what I'm saying is, I'm saying A times X gives me the resulting matrix C. To find out X, I need to remove A. To remove A, the only method that I have is multiplying by the inverse. Because if I multiply by the inverse on both sides, and remember, it doesn't matter where the A inverse is. If it's on the left, it stays on the left. Okay, don't write A inverse on the right. If it stays on the left, it stays on the left. Okay? Reason why I want this is because these two will cancel out, and that's going to become I. And we know I times X is just X. That's what we want. So, first things first is we need to find out what A inverse is. Now, the A inverse, the formula again, look at your notes. What's my formula again? Good. 1 over AD minus BC times, now in the matrix you have in the top row. Good. D, negative B on the bottom row. Good, negative CA. So in terms of your matrices, you're swapping the 3 and the 6, and you're putting a negative on the 2 and negative 1. Okay, so if I do that, this is my inverse. Notice I wrote det A because there's a special name for AD minus BC. Okay, so I'm going to write here. There's a special name for the determinant of A, that is your AD minus BC. We called it the determinant. Okay, and I'll tell you later why. And all your understanding comes from this idea. It's like your quadratic formula. It all comes from your discriminant. Your discriminant determines whether you get any solutions. It's very similar now with matrices. You're looking at the determinant. It tells you whether you have solutions or not as well. Okay? So we use det A to mean determinant of the matrix A, which is really AD minus BC here. And I've worked it out. AD, 3 times 6 is 18. Minus BC, 2 times 1 is 2. That's why I've got 18 minus 2 there. Okay? Here we go. That's my inverse. 1 on 16. I swap the 6 and 3. It's negative 2, negative 1. That's my A inverse. So according to this here, X will equal to A inverse times the resulting matrix. And here, I'm just using what you've learned so far, the basic fundamentals, multiplication matrices, add, subtract, yeah? This is your scalar product, that's your value on the outside. So you're going to multiply row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. And the ending result should be a 2 by 2 matrix. Okay, so here we go. I got my 16, 32, 16, 0. How did I get that? Let's take a step back and I'll show you what I did. So I did 6 times the 5, so row 1, column 1. Row 1, column 6 times 5 is 30. Negative 2 times 7 is 14. So negative 14. So 30 subtract 14 gave me 16. So that's row 1, column 1. To find out my next entry, row 1, column 2, I will now multiply 6 with the 6, which is 36. Negative 2 times the 2, that's negative 4. And so 36 take away 4 gives me the second entry as 32. Okay, and I do the same for the next one. Row 2, column 1 will give me the entry for row 2, column 1. Row 2, column 2 will give me the entry for row 2, column 2. Okay, so negative 1 times 5 is negative 5 plus 21. So 21 take away 5, which is 16. Okay, and then negative 1 times 6 is negative 6 plus 6 is 0. That's why I got 16, 32, 16, 0. Okay, so all I did was matrix multiplications, 2 by 2 matrix. And then finally, this is my 1 on 16. You can multiply every entry by 1 on 16. And we know that 1 on 16th of 16th is 1. 1 on 16th of 32 is 2. 1 on 16th of 16 is 1 again, and that's 0. So what was all this for? I now know x, the matrix of x, is equal to 1, 2, 1, 0. Meaning, if I took 3, 1, 2, 6 multiplied 2, 1, 2, 1, 0, that should equal to 5, 6, 7, 2. How do we feel? So far making sense? In terms of method. Okay, I'm not asking you to understand theory yet. I'm just talking about method. Good? All right. Because that's what you'll be practicing in the exercise. But I want to extend your understanding a bit and get you to really think, what does it mean when you have 1, 1, 2, 0? Like what's the point of knowing that? Okay? All right, here we go. Let's go to the next one. So what are you really doing? Well, I'm going to take the point of matrices, it's always linear equations. Okay, and that's why we only deal with 2 by 2. Later on, you can learn in methods 3 by 3, but you only learn bits and pieces. You don't actually learn the full theory. But let's just take this. Okay, and I'm going to show you what it actually really is and where the application comes from. A, okay, I've got 2, 2, negative 1, 1, x, y. So I'm now calling matrix x, x, y. Notice it's a 2 by 1, and that's a 2 by 2, and this is B. Okay? Let's say I said solve for A times x, matrix A times x equals to the B. What I have is then to solve for x, this is what it looks like. Okay? If we did this, and I'm going to just quickly, you're going to copy these as well just to do the comparison. Okay? But the same drill. A inverse, I found my A inverse. I want to find out x. According to x, it's A inverse times my B. So I'm going to do that. A inverse times my B. That's my A inverse times B. And this is my result. Okay, so here's the question. Question, what are we really doing? And this is the bulk of what you need to understand here. Okay, and that will lead back to where the inverse formula came from and why we want to know the determinant. Okay, so let's have a think about this. What did I do? I just gave a 2 by 2 matrix, and remember, so far the theory that you're going to learn and where you're going to apply is a 2 by 2 matrix. X is a 2 by 1. Notice I'm using x and y, and there's a big hint why we're using this. Then you got a resulting factor, or a resulting matrix. We've gone through exactly the same thing. To solve for x, you're doing balance of the equation on both sides, and you get this. I solved it using our basic skills, 18A to 18C, and I get this result. But we need to understand what this negative 3, 1 is. Okay? This negative 3, 1, another way of thinking about this, let's think about this now. If I gave you another perspective on what these two multiplied together actually means, A times X, let's think about it. If this is A and that's X, and this is B, just before we solve it, let's see what this actually means. Let's see what the expression actually means. Row 1, column 1. This would give you now 2 times x and 2 times y, right? So this is what you would write. You would write 2 times the x is 2x, 2 times the y, so you're adding on 2y, equals to negative 4. That goes into this entry. Row 1, column 1, row 1, column 1. That gives me a nice equation here. But what is this equation? Where have you seen this? What is this called? What kind of equation do I have there? Linear. It's going back to year 9 mathematics right now. This is a linear equation. Let's have a look at the bottom line. So the bottom line, if I multiplied it using matrix multiplication, this is negative 1 times x, and then plus 1 times y. That should give me the result for row 2, column 2. And nicely, this is actually, when you say A times X equals B, is actually another way of saying I've got two linear equations. And when I say solve for X over here, when we say solve for X, it actually just means say solve for two linear equations. Now this is simultaneous. This is what you did in year 9. So in year 9 you had elimination method or substitution method. And really that is just elimination method, what you're doing over here. But this here, if you use elimination method to solve it, let's do it. If we did elimination method, I times the bottom by 2, So I times this by 2, times this by 2, times this by 2, just so that I get the same x and y values. I got negative 2x plus 2y, times that by 2, I get 8. Using elimination method, if I solve this, add both equations, or subtract both equations. Actually, it should have been add, or actually no, minus. So minus, no, it should have been add. Oh, what did I do? Oh, I cancelled out these ones. So it doesn't matter. As long as you can cancel them out, doesn't matter which way you do it. So I chose subtraction because 2y, take away 2y, gives you 0. 2x minus negative 2x becomes 4x. And you've solved for it, x equals negative 3. And conveniently, that's what I got here. This 3 is the same thing here. So this is year 9. All we did was we represented two linear equations. See that x, y is your two variables? That's your variables. The 2, 2, 1, negative 1, 1 is representing the coefficients of two equations. If you had a 3 by 3 or a 3 by 2, that means three linear equations and x, y, z. You could have a, b, c. You're trying to solve simultaneous equations. And the lasting result is your answer. Is the answer, it's your matrix which tells you your answer. So what you're really solving here is you're finding the solution to two straight lines. Now if I solve for x and y equals 1, what does this negative 3 and 1 represent again? What does negative 3 and 1 tell me? So in year 9 you did your simultaneous equations, you got these two equations here and you solved it. What does x equal negative 3 and y equals 1 really mean? What does that tell me? What does a negative 3, 1 tell me? So what's the point of solving these two lines? What does it mean to say solve two lines? What did you just solve? What is this negative 3, 1? What is it? Anyone have a clue? Yeah. It literally is the point of intersection. When you're solving this, you're just asking, when is this equal to this line? So right now, you've got two lines, two straight lines. One has a positive gradient, one has a negative gradient. You just found out the point of intersection is when it's 3, negative 3, 1. That's what you found out. Now this is great, because if you got to what I just said, you're more than halfway understanding what matrix E is really doing, okay? Because all you're really doing now, if I ask you a simple question, I ask you, with straight line equations, if I had two parallel lines, how many intersections will I have? 0. That's why in the exercise they'll say, find when you have no solutions. If I had two lines that cross, how many intersections would I have there? 1. That's why they call it unique solution. And then if I then had two of the exact same lines, how many intersections do I have? Infinite. And this is interesting because now let's get our head around this. So there are only 3 scenarios for two straight lines. There's only 2 scenarios. That's why I said it's only a 2 by 2. 2 by 2 can only have 2 straight lines, and you only got 3 scenarios. You either have no solution, 1 solution, or infinite solutions. Because your 2 straight lines can only intersect once, or they don't intersect at all, or they intersect infinitely. Okay? Now, let's think about what this matrix is and how it links back to determinant. Why was I talking about determinant being so important? Because here, let's think about this. If AX equals B, and we said that as long as we can find inverse, we can find out X. But here's the question. Let's look at the inverse formula. Wait, did it tell you here? Yes, okay, here we go. Let's look at, we know it's now solving the linear equations. Let's look at the inverse formula. Why is this so important here? Because AD minus BC, if A was equal to A, B, C, D there, if AD minus BC was equal to 0, what's 1 divided by 0? 0. 0 divided by 1 is 0. It's undefined. So this is interesting. What happens if this is undefined? So what does that mean about my inverse? It doesn't exist. So if your inverse doesn't exist, well then, this step here, if that doesn't exist, meaning you don't have an answer for it, well, how do you get X? That means you can't get X. If you can't get X, what does that imply? Yeah, there's no solution. That's the only way. Because if you think about it, back in year 9, if I gave you this, if I said solve for 3x equals 3x, it has the same gradients, exactly the same lines. If I asked you solve for x, you're going to say take away 3x on both sides and you get 0 equals 0. That doesn't help you. Even if I gave you this, if I said, let's say I gave you an equation y equals 3x plus 1, and I gave you y equals 3x, and I said, find out what x and y is. And you try this. If you did substitution method, sub these two in, you get 3x equals 3x plus 1, you got an issue. Because you subtract 3x on both sides and you get 0 equals 1. Is that true? No, because you couldn't solve it. Back in year 9, this is a no solution problem. Why? Because these two are parallel. 3x and 3x plus 1 looks like this. Of course you have no solutions. There is no intersection. Of course you can't solve it. Why was 3x equal to 3x a problem? Because they're exactly the same line. You've got infinite solutions. How is it even possible to know one intersection? There are infinite solutions there. That's why it's so key, because the one thing they're trying to teach you in this chapter, when they say the determinant, they're just saying if this equals 0, inverse doesn't exist. If inverse doesn't exist, there is no solution. So you either have no solution or infinite solution. It's one of those two, because those two you can't solve. You can't solve when it's the same line, and neither can you solve when it's the same gradient. So when they're parallel and they're the same line, it's impossible to solve. And so in your textbook, this is what they tell you. They say when determinant A equals 0, you'll have no solutions and you have infinite solutions. And students have no idea what it's talking about. They just memorize it. They're like, I have no idea, but when it equals to 0, I have no solutions. But if you think about it logically, it makes sense because you can't solve it. And the only time you can solve it in year 9, when you have two of the same equations, or they're both parallel. Okay? So when will you have a solution? When will you actually have an intersection? When will it be possible? Yeah, greater than 0 or less than 0, as long as it's not 0. So if the determinant of A doesn't equal to 0, it's possible. And that just means A inverse exists. If this exists, you got a solution. If you got a solution, it means they intersect. It means it has to have one intersection. And this is more applicable in methods. But they'll be asking you how to find when you have infinite, when you have no, when you have one solution, a unique solution. That's the only one concept you had to learn. It's a very easy concept, isn't it? But it's not well explained because we don't really understand what's going on there. And what you're really doing is you're just finding two straight lines where they intersect. Okay? How do we feel about that? Yes? Cool? Good. I'll talk more about it in the next session, but right now, let's go to the formula. And if you like, you can learn it. If you don't, doesn't matter. Okay? I'll show you now where the formula is coming from. Okay, so we talked about this inverse. We looked at determinant. We now know what the determinant tells you. When it's 0, inverse doesn't exist. If inverse doesn't exist, then you have no solution. Okay? If inverse does exist, you have a solution. Okay? So it does cross. Two lines do cross. Now, let's think about where did this whole formula come from? This is what we wanted. We wanted 2 times the opposite times was divide, and it gives you 1. That's what we wanted. We want that number 1. In our case, we wanted a matrix, and I call it B. Okay, matrix B. As what we wanted. We want A, matrix A times B, will equal to B times A, and it has to equal to I, because I is equivalent to the 1. That's what we wanted. Okay, because I times anything will give you the same matrix. That's what we wanted. So, we want matrix A times matrix B has to give you 1, 0, 0, 1. And that's a key factor right there. Here we go. Let's say this is A. Let's call that B. Okay, let's call this A. Matrix B is what we're trying to find. We want to know what x, y, u, v should be so that when I times it to the first matrix, it gives me the identity matrix. That's what I want. Okay, so we want to solve for x, y, u, v. Let's do this. So x, y, u, v, if I actually expand it using matrix multiplication, row 1 times column 1. gives entry row 1, column 1, yeah? A times X plus B times U. That's what I did here. A times X plus B times U. A times Y plus B times V. That's my second entry. Row 2, column 1. C times X plus D times U. Right there. C times Y plus D times V. Right there. Now, the nice thing is this is a 2 by 2 matrix. And I said that equals to another 2 by 2 matrix, 1, 0, 0, 1. Why is this nice? Because we all talked about Year 9 mathematics linear equations. This is the same thing as saying this entry, row 1, column 1, has to equal to row 1, column 1 over here. It's like rabbits and shop A, the one I tried to explain last time. This is row 1, column 1, so these two have to be equivalent. So if I write it all out, AX plus BU has to equal to 1. AY plus BV has to equal to 0. If I continue on, let's see what I have. I've got 4 different equations. And what was I trying to find? X, Y, U, V, 4 unknowns. And the one thing we know back in Year 9 is if you have 4 unknowns, 4 equations, it is possible to solve. Okay, so here we go. I'm going to write it over here so we can see how am I going to solve for X, U, Y, and V, and you'll find out that's where the formula comes from. Let's do this. Elimination method is our best sort of method back in Year 9 on solving 2 linear equations. So I chose AX, BU, CX, DU, because they both have an X and they both have a U. Here we go. Elimination method, let's say I said I times this by D because I want to cancel out the U's. Okay, if you times it by the A on the bottom, then you cancel out the X's. So choose which one you want to cancel out, but in my case, I want these to cancel out. So how I did that, this has a D, that doesn't have a D. So I said times this by D, times this by D, times this by D. And this one doesn't have a B, so I'm going to times this by B, times this by B, times this by B. So if I do that, what we see is it gives me this now. So if I times this by D, it gives 80x. This is BDU. That's my D. Times this by B, that is BCX. BDU. And that's 0. Now I can use elimination method because BDU subtract BDU going to cancel out. So if I subtract it, I will now have BDU cancels out BDU. D subtract 0 is D. And ADX minus BCX. Now, doesn't that look very familiar to what you've been seeing before? Because AD minus BC. Look at that. Over here, I was doing exactly the same. I was just cancelling out the V's so I can solve for Y. Exactly the same thing, elimination method. Yeah, so I'm just timesing this by D, times this by B, so they both have the same values. Elimination method now gives me this second line, and I can take out a factor of X. So they both have a factor of X. If I took it out, I've got AD minus BC, and if you want to solve for X, divide both sides by AD minus BC. This is where your AD minus BC was coming from your formula. And I just found out X. That means I just found out this entry here. That's D over AD minus BC. If I do the same for the Y, see if I do the same for Y, these two cancel out. And then I've got ADY minus BCY. 0 minus B is negative B. Take out Y as a common factor. Divide both sides by AD minus BC. And look at that. There's your negative B. And I'll do exactly the same thing again. Elimination method, but now cancel out the Y's and work out for V and work out for U. This is where it comes from. You see, if I found out X and Y just now, that's D over AD minus BC. Negative B over AD minus BC. If you did for U and V, you get negative C and A. And the nice thing is, they all are over AD minus BC. They're all out of AD minus BC, so I took it out. That's where your determinant's coming from. That's 1 over AD minus BC, and you're left with D minus B minus C, A. And that's your inverse formula. Why? Because we were trying to find some matrix to multiply to A that gives you I. That's exactly what I did. I haven't done anything. It's just literal equations. What we did at the very start of this year, together we did literal equation solving for linear equations. That's what I'm doing here. Elimination method. So you can do this yourselves as well. Okay, it's just, there's a lot of letters. It looks tricky, But what is this really telling you? It just tells you it's possible to solve if you can find out the inverse, because there is no division in matrices. Okay, where's the application coming from? Two straight line equations, and that's all you're going to do in year 11 and 12s at high school. When you get to uni first year, they talk about how to solve 3 to 4 different linear equations. So simultaneous set, there's other methods to it. I don't teach that, so I only teach this. Okay, but that's why I'm trying to get you to understand. The determinant tells you if you have solutions or not. Those solutions is an intersection and only works for 2 by 2. 2 by 2 is 2 linear equations. That's why it works. Okay? How's that feel? That's quite a bit to take in. So you can watch this video again, but that's what you're really doing. Okay? All right. Anyone still want to copy that? We good? Okay? Otherwise, here we go. This is your exercise. Much easier than what I taught you because I'm really trying to get you to think about the mathematics. But here, very straightforward. Find the determinant, AD minus BC. Done. Find the A inverse, use the rule. Determinant B, AD minus BC. Done. Find the rule, use the rule. So all this is practicing skills. What I've done is I've taken you further and really got you to understand where it's coming from. Okay? So there you go. That's the exercise. Have a go with the questions. Pick and choose. Try to really think about it, and hopefully in methods, when you do approach this now, it makes so much more sense when you're finding no solutions, infinite solutions, and unique solutions. Okay, just get your head around the idea. It's just for straight line equations. Okay. All right. I'll leave it there. If you still have problems with multiplication matrices, let me know, because 18C, 18D is your skills. You need to work on that. Okay? On that, that's it. Thank you. I'm just gonna stop the video.